On this one, I think I'll do factoring again. It has a GCF. I'm going to factor out 15x squared. And I'm left with negative x squared plus 1. Set each factor equal to 0. And solve for x. So this time I found 3 test values. 0, 1, and negative 1. Everybody okay so far? Any questions so far I should ask? All right, so now where do I test those values again? Second derivative, that's right. So f double prime of 0, f double prime of negative 1, f double prime of positive 1. So when you put 0 into f double prime, what do you get? You get 0. That means the test fails, right? So we have to use the first derivative test. We'll come back to that one. Let's go ahead and check negative 1 and positive 1. It only fails for 0, by the way. Okay? We can still use it for the other numbers. It only fails for 0. Put negative 1 in there. If we put negative 1 in there, we get a positive 60 minus 30. So that's going to be a positive, right? And if we put positive 1 in there, we get a negative 60 plus 30. So we get a negative. So that tells me so far I have a relative min at negative 1 something. And I have a relative max at 1 something. Let's figure out those y values first. So if you put negative 1 back into the original, you get positive 3 minus 5, so negative 2. If you put 1 in there, you get negative 3 plus 5, which is positive 2. Now remember, you can have more than one relative min or relative max, or sometimes you might just have a relative max and not a relative min, or vice versa. So we still have to test this 0. But we have to do it using the first derivative test. So I'm going to test negative 1 to 0 and 0 to 1. If we were doing the first derivative test, by the way, we would have to do negative infinity to negative 1, negative 1 to 0, 0 to 1, 1 to infinity, right? We would have to create that big, gigantic chart. But we are only testing at 0, so that's why I just picked those 2 columns on each side of 0. So remember with the first derivative test, you test into the first derivative. So I'm going to test a half and negative 1/2 into the first derivative. And since I've got some fractions in there, to save me some time, I'm going to punch it in my calculator to see if it's positive or negative. So negative 15 times 0.5 to the 4th plus 15 times 0.5 squared. And you know what? It really wouldn't matter, because if you look at f prime, they're both being raised to an even power. So negative 0.5 and positive 0.5 are going to have the same sign. It turns out that they're both positive, but you technically wouldn't even have to check it, would you? If you just think about the fact that when you raise negative 0.5 to the 4th power, you get the same thing as when you raise 0.5 to the 4th power. Same thing with squared. They do turn out to be both positive, but that just means that there's no relative extrema, right? If it had gone from positive to negative, there would be a relative max there. If it had gone from negative to positive, there would be a relative min there by the first derivative test. So I'm just going to say neither. And I'm going to say by f dt, first derivative test. Neither by the f dt, first derivative test. Okay, any questions on concavity test or the second derivative test? I do need to give you an assignment for this section. It's going to be on page 189. So page 189, I want you to do the following numbers, 11 through 19 odd, 31, 27, 29. I know that's out of order, but I'd like for you to do it in that order.
In that order?
Just, yeah, I'd like you to do 31 and then go back and do 27 and 29. All right.